Hello class and welcome back. I want to give you a quick rundown on sort of what the setup's going to look like for lab number two. So lab number two, we're looking at projectile motion and linear kinematics, looking at objects that are accelerating and then moving through the air as well. Okay, so there's two parts to today's lab. In part A, you need to create some sort of a ramp. So what I did was I just took and cut out a piece of cardboard here from a box we had, and I actually tried to keep one of the creases so that I can have a ramp sloped with the flat part at the bottom, because what you're going to be doing is you're going to be taking some sort of a marble or a ball or something, setting it on the ramp and letting it roll down the sloped portion where it will accelerate, and then you're going to have it go for a short distance along a flat horizontal portion. This is probably about as long as you want here, about 4 or 5 inches. And then it's going to go off the edge of your desk. So you're going to want to set this up somewhere near the edge of a desk, something like this here. You can't really see that well. But let's say we're doing it here, something like this, where the slope comes down and then it rolls off and then it's going to fly and hit the ground. So what you're going to be doing is you're going to be analyzing the acceleration rate as it goes down the ramp based on the geometry. You should be able to calculate what the acceleration is, and based on how far up the ramp you're starting it, if you notice I have 3 different marked points where I'll be starting it. If you know that distance and the acceleration, you should be able to calculate what its velocity is at the linear part. Then if you know that velocity, its velocity is only horizontal as it exits the desk, and then it's just moving through the air, and the only thing acting on it once it's in the air is gravity. So you should be able to predict, based solely on knowing how far up you're starting and the angle of your ramp, you should be able to predict how far away from your desk on the ground the ball is going to land. That's what you're going to be testing. You're going to be testing it for 3 different locations on your ramp and doing multiple trials of each one. So again, just to kind of show you what a test is going to look like. I set up my ramp off the edge of a desk. Maybe I'll angle this a little bit more so you can see. I'll set this to my first mark, let it go, roll, and I'm going to look at where it lands on the ground. A pro tip for knowing where it lands. It's a little hard to tell, especially on like a hard floor like this. Even on carpet, it's difficult. Although I would recommend using carpet if you have it. But what I'm going to do, if I were to do this, I would take a small piece of aluminum foil, if you have any around the house, lay it down on your carpet or your ground where the ball is going to land. So do a couple practice trials to get an idea of the approximate location, and then place that piece of aluminum foil down, and you can see an indent exactly where it lands. And then each time you do it, maybe just take a little marker and cross it off so you know that that's the previous trial, and then you'll see a new indent each time. All right, so again, you're going to do multiple trials at each location. That's for the ramp portion. That's part A of the lab. Part B is a tricky one. Now we're going to be looking at projectile motion. So for this, you're going to need some sort of a launcher. I recommend like a simple kind of slingshot, something like this. You can, if you want, use like a Nerf gun, kind of like this. The problem with this is Nerf darts experience a lot of air resistance, so you're more likely to have error, air due to air, with the Nerf gun. Even like if you have any other, like this is probably something not a lot of you have, but I have from the physics lab, a little kind of spring-loaded cannon. But you really want anything that can launch an object somewhat consistently with a consistent velocity. And so what you're going to do is you're going to take your object. So let's say you're using a slingshot like this, or a spring launcher or some other similar device. All right. What you need to do is you need to make sure every single time you pull it back the same distance. And you're going to start by shooting it straight up based on how high it goes and or the hang time, depending on which one you're able to measure more accurately. I recommend measuring height because it ends up giving you better data. But if you're not able to do that, you probably need a friend to help you to get the height. If you're not able to do that by yourself, you can still get the hang time using a timer. To make sure you launch, though, the same pullback distance every time, I recommend getting a ruler or some sort of object that's a steady size. And so here I just found like a bin I can sort of clip this to. And what I'm going to do here, if I want to launch this straight up, all right, I'm going to take and set the slingshot so that the kind of launching location, the point where the ball sits in your slingshot, is at the top of my ruler here. Okay, going to hold it steady, and then I'm going to pull it down to the very bottom, and that's where I would release it from. With this, the top of the ruler being my zero location. for when I'm doing my projectile motion calculations, all right? Because that's where the slingshot is no longer going to be influencing the ball, and it will only be under the influence of gravity. For all of projectile motion, we're assuming that the only thing affecting it is the acceleration due to gravity. So anytime that the slingshot is still influencing it, we need to ignore, all right? So you want to set it up like this, or you could, start with the top of the slingshot at the top of the ruler, but then this would be your zero height, however you want to do that, okay? It's up to you. But if I, kind of set it up here, I just pull it down, launch it straight up multiple times, and use that to calculate the initial velocity. Then I'm going to have you launch it at an angle. Now for launching it at an angle to test the range equation, again, you want to pull it back to the same height. So what I would do is I would use my same setup that I have here, okay? Get my ruler clipped to my bin here. Again, maybe I'll tilt this down just a little bit so you can see. Again, I'm going to have my 0 point be at the top of the ruler, and I'm going to pull this back parallel to the ruler. So I can use the ruler as it's set up here as my measurement for my angle. So I can either just use geometry to determine the angle that this ruler is at, or I can use a level app on my phone or a protractor if I have one. So now I'm going to be launching at this angle. Again, this is going to be my 0 height. I'll pull back from here parallel to my ruler, and then I will be able to launch from here and use the range equation to predict how far it's going to go. Very important though, the range equation assumes that your starting and ending elevation are the same. So if this is my starting height, my landing location where I measure where it lands, again, I'd recommend using aluminum foil, must also be at this height. So you might need to get a couple boxes. So if I'm launching here, and if I assume it's going to land right here, I would need to get a couple boxes so that they're exactly even and level at the same height to put my landing pad here, because again, the range equation assumes the starting and ending elevation are the same. So again, you can do a few launches at this angle, then you might change and make it a lower angle, something like this. All right, then you could launch a few at that angle. You might want to try a much steeper angle, so you'd elevate it like this. Again, do a few launches there as well. Keeping in mind, every time you want the same initial velocity, all right, that you had when shooting it straight up. So you want to make sure you're pulling it back approximately the same distance every time. So again, every time, if this is your 0 point, pull it back to the bottom of the meter stick or ruler, no matter what, okay? So that's kind of a rundown on ways in which you can get set up and do lab number 2. If you have any questions on it, just let me know. Thanks.